Welcome to Study Loop.
All right, for this problem, we're going to enter a decimal number and convert it to a hexadecimal, which is base 16. So hopefully you've got a good feel for what base 16 looks like. If not, hopefully this will help. So we're going to say enter a decimal integer. And we get that decimal integer from the user. And then I'm going to go ahead and just create a variable called hexnum. And I'll make it a string, and that'll be the output. And so I'm just going to keep processing decimal number and making it smaller, processing, making it smaller. Eventually it'll be 0. So I'm going to say while decimal number is greater than 0, that means I'm not done yet. All right. So I'm going to go ahead and use a variable called bit. I don't need it outside of the while loop. And so bit is equal to decimal number. If I divide decimal number by 16, bit is going to be the remainder. And then I'm going to say bit string is equal to, I'm going to convert that bit value. Helps if I spell number right. Convert that bit value into a string. And so now if you know hexadecimal, though, it's possible when I divide 27 by 16, I'm going to have 11 left over, and I don't want to print out an 11 because that's going to get really confusing. And so I need to just do a series of if statements. We could do elifs if we wanted. That's probably a little bit more efficient. But if the bit value is equal to 10, then bit string is equal to A. And I need to type all these down. I'm going to go ahead and use some copy and paste. So that's for 10, 11. Ooh, let me undo that a little bit. Let me add that. So now I can go to here. I don't think that's going to work either. Yeah, I don't like that. I can fix that. So that's 10, 11, 12, 13, 14, 15. And I could have done that smoother. But in a second, you won't notice how badly I did that. Okay, and so this right here is 11, 12, 13, 14. And the biggest remainder I can have is 15. This right here is a B, C, D, E, and F. All right. Okay, so I've got my least significant digit, and so my hexnum is going to be equal. Each time I do this, it's going to add on to the right, not the left. Really hard to explain without a whiteboard in front of me. And so if you're not understanding what's going on, I really recommend you run through this a couple times with numbers that you know the hexadecimal value for, so you can see why it works this way. But I'm going to say bit string plus hex number. Okay, it really does work. And then I got to do two things to my decimal number. The first thing is I have to subtract whatever my bit value was, so that the number is now evenly divisible by 16. And then I have to divide it by 16. And so once I get rid of the least significant digit, this will basically shift the whole number by a factor of 16, and then I can figure out what the next least significant value is and add that just to the left of the previous one, and keep doing that until my number is all done. And then Gosh, I hope this makes sense. It does to me. So if you're not sure what's going on, this is a good one to just really walk through it with numbers. So let's go ahead and run it. I know the number 35. Nope. I know the number 35 is 2/16 plus 3, and so I should get a 23, and I do. And then you can keep running it and testing other values, but it really, really does work. Let's go ahead and do, let's do 1600 and see what happens when we do 1600. 640. So if we did the math, that would be 664s, 416s, and then a 0. And I'm going to go on a limb and say that all adds up to 1600. That's how you solve this particular problem.